Hi guys, how's everyone doing out there? We are going to be going through chapter 1 today, and really chapter 1 is just an introduction to these earth and sun relationships. Okay, so some things I might just skip over, and then some things I'll go into more detail with. Okay, so it's really just introducing the discipline of geography, really what chapter 1 is about. So I always start off the class with this beautiful picture of Earth. This is also known as our blue planet because in the solar system, it's the only planet we know so far that has water, right? And, you know, science is ever changing and we're always learning new things. We just learned that aliens are real, right? So it could be that other planets might have water, and there is sign of frozen ice or frozen water on, I think it's one of the moons of Jupiter, Europa. I might be wrong. Again, I don't know very much about the solar system. What I am well versed on is our planet. But it's so interesting, right? I wonder, like, you think about all those people long ago who used to think about aliens and talk about aliens, and people are like, oh my God, you're crazy. And now it's just like, oh yeah, they're real. That's kind of wild to me, but that's science. I love science. Today's objectives. So this would usually be more for an in-class lecture. I would talk about what we're talking about today. And this is really just for you kind of have this outline of what's going to be going on today. But, you know, for this type of distance learning environment, this is not very necessary. So geography and science. Geography really encompasses several elements of science. So it's a very broad discipline, and depending on what you tend to focus on, if you're a geography major, you can go in many different routes. So the actual word itself, geography, comes from the Greek word meaning earth description. So geo, obviously earth, right? And graphy means to scribe or to write. Now this is going to be a question on the exam. For sure it will be. And when I remember anything that shows up on your lectures that I know for sure is on the exam, I will tell you guys. But I know this is a question on the exam. I think it's like number 1 or 2. What does geography actually mean? It's really to just describe the earth, and that's what we're doing. We're looking at different landforms, different features, vegetation, plants, animals, humans, and we're describing them and their relationship with other things along the surface of Earth. I get asked this question a lot because, believe it or not, there is always a student who says, hey, Miss Barajas, I freaking love this subject. I want to be a geographer. What can I do with a degree in geography? Well, there's a lot of different things. You can be a climatologist, cartographer, GIS specialist. You can be a teacher, transportation management. I mean, all these things. You guys can read through this yourself. Elements of geography, it encompasses a lot of different sciences. So it would be a physical science, right, or a natural science, physical geography, and also a social science. So depending really what school I'm teaching at, geography is in a lot of different departments. So for Fullerton College, I'm in the social science department, geography. And for Cerritos College, I'm part of the SEM, or science, engineering, and math department. So it just encompasses many different fields of science. So like for cultural geography, you would be looking at population, economic activities, religions, political systems, animals, soil would be for the physical side, for the natural side, right? So that's what I love about this subject, is that it's not just all one thing. right? If you like social sciences a little bit more, you would definitely go into that human aspect or the cultural aspect. If you're very black and white and you just like data or science, or it's either this or that, right? Like for me, I'm more of the physical side, right? But you can't ignore that the other side exists because everything is related. How geographers study and how they look at the world. A lot of times people think, hey, geography, you're a geography major, so you know where, I don't know, Nebraska is? I probably do. But what I'm trying to say is that geography is not just about maps. You're looking at the world geographically, and I still don't know where everything on Earth is. There was never a class that I took that quizzed me or tested me on states and capitals when I was doing my when I was getting my degrees. So it's funny when I talk to people that I don't know, or when I meet people and I say, yeah, I have a master's in geography, they assume it's all about maps, when in reality that's just a very, very small portion of it. It's really how we are looking at and surveying the world, right? We're looking at relationships between many different things, and it's really based on location. So this word interconnectedness and interrelationships is going to come up a lot um, in this semester. So really geography is really looking at how things differ from place to place and drawing interrelationships or connections between those. So because geography is really this wide scope, right? It's kind of bridging the gap between the natural and the social sciences, so we can draw connections. For example, why people migrate from place to place has a lot to do with climate, right? And landscapes, location, topographical features, mountains. So it's not like you have to ignore the two. Those two are completely related. So two themes that we're going to see throughout the course and the book is global environmental change. These are human-caused and natural processes that are altering our landscapes. Yes, we can all agree that as humans, we are completely changing the landscape, that we are changing the climate. Yes, but that does not operate separately. It's kind of like this two-pronged effect. Climate change is a natural process. We are naturally always changing. There's always something happening that our climate would change over time, over a long period of time. But now we can add that, or we can actually say that our impact as humans is also kind of exacerbating that, where we're just kind of, we have our hand on the throttle and we're really pushing that change, right? So climate change deniers will say there's no possible way that man can change the climate. And that's a good argument. But as a scientist, I can tell you, yes, the climate is changing naturally, and we'll look at how that happens. But you can't ignore the fact that humans are adding too many fossil fuels, too many emissions into the atmosphere, which causes warming. And globalization, right? Globalization, you probably learned about this or talked about this in a different course. Globalization is the processes and consequences of an increasingly interconnected world. So you need to know this definition for the exam. What is globalization? And here is the actual definition. That's exactly what I would write down right now if you're taking notes. Examples of globalization. What's an example of globalization? So maybe going to a very far, desolate place, I don't know, in the middle of Russia or the very northern part of Siberia, or even in the Amazon rainforest, right? And finding things that, okay, sorry. So maybe going to China, right? I went to China in 2011, and in some places, it doesn't look much different than here. And that's because we're more connected than ever before. Why are we more connected? Because of technology, advances in technology. Things travel at a higher rate than before, right? I mean, everybody knows pretty much everything pretty quickly. And a great way that happens, or a good example of that happening, is the news, our connection with the internet, right? So things look like each other more. News travels much more quickly. It's more globalized. 5 spatial themes of geography. These are very important, okay? So first spatial theme, and this will be on the exam as well. Again, chapter 1 is like introduction to the entire subject. But these spatial themes you will see in every geography course that you take. First spatial theme of geography, location. Location tells us where. So for instance, the latitude and longitude, that is the actual location of a place, right? Like Los Angeles, California, I think it's 32 degrees north, 118 degrees west, something like that, right? It might be off by a degree or two. And you know that because that's a pinpoint specific location. I mean, I'm sure you've seen people that have tattoos right here and they're like, oh, this is where I met my lover, whatever, right? So that's a specific location. What's the difference between location and place? Well, place holds a uniqueness, right? For instance, place, it has a unique characteristic or quality that makes it special. Should I say that? For instance, Venice Beach, California. Well, that place is completely unique, right? East Los Angeles, California. It's unique. There's no place on earth that's like East LA. And we'll talk about places in Japan that are kind of like, there's this subculture of like that low rider look, which I think it's cultural appropriation, and some people argue and say that it's like admiration, but that's a whole nother topic. But what I'm trying to say is that different places on earth have this unique value, and you can argue and say that places are losing that uniqueness because of globalization. Good. So location, place, they might sound similar, but there are differences to those two words, so to those two themes, okay? Location tells us where, place is the uniqueness of these locations. Movement. So when we look at movement, it could be really the movement of anything. How ideas travel across a landscape. How diseases travel quickly. Pandemic. This pandemic we're living in is a great example of that, right? Anything that spreads out and diffuses across the landscape. And again, globalization is really aiding that movement in it happening quicker than ever before. I mean, if we didn't have any means of travel, it could be that, you know, the virus maybe would have never got here and we would have controlled it before, but we would have never known about it without this technology, right? And then region. So location, place, movement, region. When we look at region, what geographers tend to do is you take similarities and you group them together. For instance, the United States. What is the United States broken up into? States, right? How many? Good. I hope you guys know how many states we have. But that's an example. Or like the ocean. We have one world ocean, but it's broken down into a lot of different oceans or smaller names. And the reason I keep looking up here is because I have my world map up here. Or let's see, California, right? California, even if it's not technically broken down into different regions, if you've been born and raised in California, you know that people in Northern California are like completely different than people in Southern California, right? When I went to San Jose State, I was like, people knew right away that I was not from NorCal or the Bay Area. They knew that I was from LA. I knew that things were different there because they even talk different, right? Everything's hella this and hella that. And before that, I had never even heard that. It was really weird to me. Central California, Northern California, Southern California. The Inland Empire should be like its own land, right? Like the high desert. What the heck is out there? I'm just kidding. But do you understand how it's one state, but things are so different within those regions? Okay, so we'll look at this later on. We'll take different ecoregions, like all the rainforests are pretty much found along one belt. All the deserts are pretty much found in the same area. So that's what we're doing when we look at regions. We're just making things more understandable, more organized. Human and Earth relationships. This is the most important theme of geography. And if it sounds redundant, if your professor keeps talking about something, if it's like sounds redundant, then it means it's probably going to be on the exam, right? So human and Earth relationships, how do we affect humans? How do we affect the Earth, we as humans? Do humans affect the Earth? And if you guys did the module from last week, you should know that yes, we do affect the Earth. And you can argue and say it's a good thing. And some people argue and say we suck, right? I think we suck as humans. But I just think it's not like we're purposely doing things. I just don't think we're doing things sustainably, correctly. So as our population grows, the natural resources on the planet, which are limited and finite, are really suffering, right? So here it is again, resource consumption. We have talked about this already. Consumption is a human use of materials and energy, and we watched that video already, and we had discussions about this already, right? Consumption can be both economic and social. Today, our identity here in the United States is mostly, our identity is how much we've consumed. What car, think about the shoes that you're wearing, right? Fashion. It tells other people like, oh, I just recently bought this. So I have more value than a person who has not recently bought this up-to-date shoe. I'm not saying that everyone feels this way or that every group thinks of things this way, but it's an overlying issue, and I would say problem here in the United States. But there is silver linings, right? There is things like recycling clothing that's becoming more, I don't want to say trendy, but it kind of is cool now to like be green, which I love. The younger generation, you guys are doing a great job at purchasing mindfully and just being mindful of things. So I don't have to spend any more time here, you guys. We did have a whole module about this. Okay, so let's go into environmental spheres and Earth systems. Just like I said, geographers like to take information and break it down into more organized forms or just find similarities and patterns. So when we look at the planet, we look at the globe and we break it down into different spheres. So like the lithosphere, that would be all the rocks, the soil, the minerals, the inorganic portion of Earth. The mountains would be part of the lithosphere. Okay, so following that same kind of rhetoric, what would the atmosphere be considered? Obviously, all the gases, all the atmosphere, right? How about biosphere? Well, the biosphere would be all living things. You, me, plants. I love plants. Maybe I should put this girl over here, right here. But plants would be part of the biosphere as well. And then the hydrosphere would be everything that is water, right? The ocean, lakes, rivers, streams, reservoirs, all those things would be part of the hydrosphere. And the cryosphere would be everything that is frozen. So we're just taking the Earth and we're breaking it down in different spheres. And it's important to remember this because maybe in the future, or most likely in the future, I will be using these terms. Use biosphere instead of all living things, or use lithosphere, right? So here's this picture. I think it's pretty straightforward. Atmosphere, cryosphere, lithosphere, biosphere, hydrosphere. Pretty easy, right? These spheres, these 5 spheres, are not separate entities. They are interconnected, and they're important because they serve to broadly organize. And again, as geographers, we are broadly organizing and finding patterns within the planet or on the planet. Okay, so let's go on and let's go into Earth and the solar system. So when I was growing up in the 90s, I learned that Earth was part of one of 9. That's where I'm getting to. Sorry, guys. One of 9 planets, right? And I never heard the news that we are now 8 planets. I think I was already older. So when I came back to start teaching, that's when I found out that there was 8 planets. Maybe I was too busy partying during that news announcement. So we are part of 8 planets, right? Earth is one of 8 planets. I think Pluto is just considered too far away or too small to be considered a planet. Anyways, we are part of 8 planets. The sun is the central body, right? We revolve around the sun, correct? And remember that our Earth is not flat. So hopefully, I don't have any flat earthers in my course this semester. I've always asked, but I wonder if anybody would even admit to being a flat earther. And hey, I'm all for conspiracy theories, but that one just doesn't sit with me. Maybe because I spent like $30,000 getting my degree that I still cannot pay off, but I spent a lot of money proving that our Earth is not flat. Where am I going with this? I don't know. Our sun is the central body. We revolve around the sun. We're part of the Milky Way galaxy. Origins of Earth, that's also left up to you, whatever you believe. If you believe we were created, or if you believe in the Big Bang Theory, I'm not here to discuss that. I'm not here to tell you you're right or wrong. But what we will look at is our relationship between the Earth and the sun. Let's just keep it very black and white. There's already enough conspiracy crap going on in the world today, right? The size and shape of Earth. In comparison with the universe, the Earth is infinitely small. Right? We might think that the Earth is this huge planet. Yes, in our capacity, in our mind, it's huge. But it's part of this infinite galaxy, an infinite universe, right? So in the human frame of mind, our Earth is impressive in size. When we look at Earth, it's not actually a sphere. The actual shape of Earth, I mean, this is a horrible example because this is probably just a decorative globe. I should go get my real globe. It is an oblate spheroid, oblate. So meaning that is not perfectly a sphere. It's more like fatter at the equator because the Earth is constantly spinning and it's been spinning for many, many years. It starts to fatten at the equator. So the equator is right at the middle. And I'm kind of getting ahead of where we should be, but I'm still not used to like looking at the camera or here. So if my eyes look crazy, it's just because I don't know what to look at. So we'll talk about the equator in a bit today, okay? But the shape of Earth is an oblate spheroid. That is very important, not only for obviously your exam, but when we look at the reason why we have spring, summer, fall when we do, a big reason for our season is the shape of Earth. We're not a perfect sphere. We're a little bit fatter at the equator, okay? Highest point and lowest point on Earth. Highest point is Mount Everest. It's about 29,000 feet above sea level. And Mount Everest is in the Himalayas here, northern part of India. Well, the northern part of the subcontinent of India. And then the deepest spot on Earth is in a trench in the Pacific Ocean. It is the Mariana Trench, and it's deeper than Mount Everest is high. And these pictures here are actually pictures of life that has been found at the very, very bottom of this trench. And we'll talk about this later on in the semester, but you know, for a long time, we as scientists thought like you needed sunlight for photosynthesis, but there are creatures and life, there is life at very, very deep places that don't need light. They don't need sunlight. They have found a way of using energy from within the earth and mimicking photosynthesis. So it's called chemosynthesis, and they're able to have this life without the sun, which has kind of really changed and rocked the scientific world, because now we're thinking in other planets, if there is no light, that doesn't mean that there is no life. Does that make sense? So if there is signs of oceans on other planets, then it's like, how smart are their clams? Are they already past us? Or are they just now evolving? You know, so I know it's getting kind of crazy, right? Well, now we know that there is aliens. That's crazy. I'm still not over it, guys. This is like crazy to me. This is the Mariana snailfish. What a cutie patootie, right? Disgusting. Deepest dwelling fish species discovered so far, and I could be wrong because this was written maybe, I think this lecture is a little bit old, but I haven't updated it, so it could be different because, again, we are discovering different things almost every day about the ocean. When we cut the Earth at the equator, it is longer than if we cut it from pole to pole. Why is that? Because we are an oblate spheroid, right? So instead of being like a perfect circle, you are fatter, and this is a very exaggerated picture, fatter at the equator. So it would be longer this way than it is this way. Okay, so you know, for your exam, for your diameter of the Earth, I will give you one number because there are two different numbers, right? So pole to pole, it would be 12,714, and at the equator is 12,756. But when you get your study guide, you will have the number that I will use for the exam, because I wouldn't ask you those two different ones. But it's close to 12,700 kilometers. Close to that. The geographic grid. So we have this huge planet, right? How do we locate features on the planet? So there has been something that geographers have developed to pinpoint exact locations. Again, as geographers, you try to find patterns, right? Has been created in order to understand accurate location. So you have latitude. These are the lines running this way. And longitude, long. Latitude sounds like a ladder, and those lines run like this. That's how I remember it, okay? So we're going to be going through latitude and longitude. Latitude is a line connecting all points of the same latitude. They're called parallels. Why do you think they're called parallels? Because they're parallel to each other, so they never intersect, right? They are parallels. So let's look at this picture here. Here's a great picture for our lines of latitude. It starts at 0 at the equator. It's kind of like this natural baseline. The equator is at 0, and it runs all the way up to 90 degrees at the North Pole and all the way down to 90 degrees at the South Pole, okay? So if you're in the top portion of the equator is the northern portion, because this is the northern hemisphere up here. Southern portion is southern hemisphere. So if you were up here, it would be 50 degrees north, and then down here, obviously, it would be like 40 degrees south, 50 degrees south, okay? So they run up and down, and in between, yes, there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's broken down even more, but these are like this is a main way. By tens is a good number to show you guys, okay? So these are lines of latitude. There are 7 very important latitudes that are going to come up the entire semester, and these are just like latitudes you should know. You're going to be quizzed on this, and there will be this on the exam. Okay, obviously you have your equator, right? That's at 0 degrees. And then, actually, I'm thinking of how to do this right now. Let's do like this, right? So you have your equator, runs at 0 degrees. And then you have your Tropic of Cancer. It's at 23.5 degrees north. And your Tropic of Capricorn is at 23.5 degrees south. How do I remember that? Is 23.5 degrees north, the Tropic of Cancer. If you know anything about like your sign, Cancers become before Capricorns. I don't know, that's how I remember it. Then you have your Arctic Circle. It's at 66.5 degrees north, and your Antarctic Circle is at 66.5 degrees south. And then up from that, you have, above that, you have the North Pole or the South Pole. So these are your 7 latitudes, 1, 2, 3, 4, 5, 6, 7. So know this. I would take some time, pause it here, draw a circle in your notes, draw out those latitudes, and remember the degrees of latitude. Okay, these are degrees you have to remember the entire semester. Lines of longitude are expressed, again, they're also imaginary. Obviously, you don't like go to the equator and you don't see the line. Expressed by imaginary lines extending from pole to pole and crossing at all parallels at right angles. These are lines called meridians. These are not parallels because they cross at the pole. So they go 0 all the way to 180 on one side, and same thing to the other side. Now, what I do need to tell you, I don't know if you guys know this, but we have different hemispheres, right? So you have the Earth, you have the northern hemisphere, obviously the southern hemisphere. Then you have the west side, the best side, western hemisphere. Then you have the eastern hemisphere, okay? So everything on this side would be 10 degrees, 20, all the way to 180 degrees west. If you're going up, it would be 10 all the way to 90 degrees north. This way would be east. Does that make sense? And then how would you find like latitude and longitude? So here's the Earth. If I give you 10 degrees north, 110, or let's do actually 110 degrees east. So you have your Earth, you would go up 10 degrees north because it's in the northern hemisphere. Now east would be this way, right? So you find a 110 degree line of longitude along with a line of latitude. It would like be here, right? That's how you would use latitude and longitude. You can have 5 degrees south, um, 60 degrees east or west. You would go down 5 over 60. It would be here. This is much more difficult teaching like this. But if you guys have questions with that, email me, let me know. Hopefully that helps you. All right, the last portion of chapter 1, we're going to be looking at Earth-Sun relationships. So why do we have the seasons that we have? and how that happens and what is the relationship between the earth and the sun, because out of everything, that is one of the most important relationships. Okay, our day length, depending on the hemisphere that you're at, you're in, the season that we're experiencing, and really what gives us the march of the seasons. That's what we call it, the change of the seasons. The relationship between Earth and the Sun is of the most importance. It does not remain the same all year long. It changes, and we know this, right? Because right now we're in August, and it is hot as balls in August. It's hot, right? It's super hot today, but it's not because we're closer to the sun. So we'll look at the different reasons why it is hot in August and not in December. Okay, so that's really what we're going to go through today. Okay, we got to think about Earth and the way it moves. So we can agree that it rotates around the sun, correct? Rotates around the sun, and it revolves on its axis. So there's an imaginary line in between, and it's rotating on its axis. Okay, so rotation and revolution, and I'll have a really cool video on your module that will explain it a little bit, I guess, just differently, so you guys can really understand this. And Earth's rotation on its axis, it rotates from west to east. All parts are spinning except the poles. So depending on latitude, right, some latitudes are spinning faster than others. The speed of rotation varies by latitude. Which latitude do you think is spinning the fastest? So this is more like of a physics critical thinking question. Which latitude do you think is spinning the fastest? Do you think it's the poles? Do you think it's closer to the equator? Which latitude do you think is spinning the fastest? So the answer is the equator. The equator and the latitudes closest to the equator are spinning the fastest. At the poles, it's not really spinning at all. So this is important when we start to look at hurricanes and the way hurricanes move across the landscape. That's important because they're not going to go straight up or down. They have to account for that spinning momentum. All right, so remember, the closer you are to the equator, the faster the Earth is spinning. Rotation has several important effects. Obviously, our day and nights. How long does it take for one full rotation of Earth? It takes 24 hours, okay? For us to rotate one complete rotation is 24 hours, right? The Coriolis effect is a very important effect that rotation has. So if I had like magic powers, right? If I were Santa Claus and I was up here at the pole with Buddy the elf, right? Earth is spinning and I want to throw a package to my friend at the equator. All right, if I have Santa magic, okay, because he's magical, and I'm throwing a package down to the equator, is it going to land straight the same trajectory that I threw it if the Earth is spinning? And hopefully you're saying no, okay, because what it'll do is it's going to conserve that momentum, right? So when we look at winds moving this way across the land, they're going to deflect. So it causes a deflection. Same thing if you were at the equator and you're throwing a package up to, let's say from Brazil to Washington, D.C., it's not going to go straight up. It's going to, conserve that momentum and it will deflect. So deflection is the Coriolis effect is a very important effect of rotation, and I will have an activity with this video, but this PowerPoint will go up on Canvas and you are able to go through it, click on this video. If there are hyperlinks on here, I cannot record this lecture and click on it. It just doesn't work. But you're free to do that yourself. And they're actually really good videos that go along with my lecture, and they do help a lot. Earth's revolution around the sun. We know one rotation takes 24 hours, correct? One revolution around the sun takes how long? A year, right? 365.25 days. We're accounting for that leap year. And the fashion or the trip, the way that it goes around the sun is not in a perfect circle around the sun. So here's the sun, and here's the earth. It's not going like in a perfect circle. The trip it takes is an ellipse, like elliptical fashion, okay, like this. That's kind of very exaggerated. Two important dates are perihelion and aphelion. The day in our trip around the sun that we are closest to the sun is on January 3rd. And the day in the year of our trip around the sun that we are furthest away from the sun is on July 4th. Is that weird to you guys? Yeah, it should be. It should be like make you question, right? Well, why on 4th of July is it so hot? And January 3rd, that's winter. It's super cold. Well, what I want you guys to think about is that our proximity to the sun, write this down, has nothing to do with our seasons. How close we are to the sun, it doesn't make it hotter or colder. Does that make sense? Our seasons happen for different reasons, but our proximity to the sun is not one of those reasons. Okay, so here is a few other things that I want you guys to remember. Our Earth is not straight up and down. Instead, it is at a tilt, and that tilt is at 23.5 degrees. Okay, it's tilted towards the North Star. So the North Star is here, the sun is here. The reason this is kind of confusing is because it's supposed to be like this, but it's flipped. Does that make sense? So I'm doing it this way. So the North Star is here, South Star is over there. The tilt, the northern hemisphere is facing that North Star, and the Earth goes around the sun like this. Okay, here's the sun. It's going around the sun. Okay, so depending on the time of the year, the northern hemisphere might be tilted away from the sun or towards the sun. Does that make sense? So here's the sun, right? And the Earth's going around it. So the northern hemisphere where we're at, when it's tilted towards the sun, guess what? We're in summer. When it's tilted away from the sun, we are in winter. Southern hemisphere is in summer. Whoa, that was a lot, right? But I have a few slides that's going to explain that a little bit more. So the inclination of Earth's axis, we're inclined, we're tilted 23.5 degrees. Polarity, that means that the axis is facing the North Star. So these are really like fancy, sciencey words, but a lot of times people, students in particular, are kind of put off by these fancy words. And you'll find this a lot in academia, but don't let that scare you. Just understand the meaning of it. All it means, polarity of Earth's axis, is that the North Pole is tilted towards the North Star. So it's never doing this, right? It's just staying like this. You guys got that? Remember, the most fundamental feature, the biggest reason of our different seasons is the orientation of the North Pole and the sun, right? If the North Pole is facing the sun or tilted away from the sun. All right, so these are very important. Pause it here, write this down. What are the 5 reasons that we have different seasons? So my mom would say, Jesus is the reason for the season. She has this little pin she brings out in December. Really cute. But the reason for the seasons is number 1, Earth's shape. What's Earth's shape? Oblate spheroid. Yes, it's not a perfect sphere. Remember, it's fatter at the equator. Another reason for the season is Earth's rotation. It rotates on its axis. It's always doing this as it goes around the sun. Got that? And then we have the inclination of axis. It's tilted towards the North Star. Okay? It's not tilted this way, although it will over time change, but that's a whole nother topic. It's tilted towards the North Star. Earth's revolution, it revolves around the sun in how many days? 365. And polarity of axis. So the distance from the sun does not play a role on the seasons. Remember that. That's in bold. What do you guys think you should do? Write that down. Underline it. Put a star next to it. Okay, let's go through every single season and then we'll be done for our first lecture today. Okay, so let's start with summer. It's going to happen on or around June 21st. I think this year, first day of summer. I think this year it was June 21st. So just to keep things all the same, I just put on the 21st, okay? So June 21st, maybe June 22nd sometimes June 20th, is going to be our first day of summer, okay? So the northern hemisphere is tilted towards the sun. Here's the sun, right? The vertical rays of the sun strike the Tropic of Cancer, 23.5 degrees north. The Arctic Circle up here, right above 66.5 degrees, they're going to get 6 months of complete daylight because all the while they're going this way, they're getting that daylight. And the Antarctic Circle, they get 6 months of complete darkness. I hope this is helping you guys. It's really weird to teach like this. Okay, so that's the first day of summer. Okay, what comes after summer? Maybe it should be this way. This is really throwing me off. What comes after summer? Summer, fall, right? Fall is my favorite time of year. I love fall. Pumpkin spice everything. I also love fall because I love Halloween and my birthday is in October. So I'm a fall baby. So fall comes next. So here's the sun. The earth comes around this way. Now neither the northern nor the southern hemisphere is tilted towards the sun. Only the equator is getting the direct rays of the sun. Okay, this is a few months later, right? The northern hemisphere, we're in fall, so the southern hemisphere is in spring. Oh, and I forgot to mention that. When we're in summer, the southern hemisphere is in winter, okay? And I'm going to have a better video. This is probably making you more confused. Hopefully not. Hopefully it's helping you. But I will have a better video on the module. And then after fall, we come around this way. Now, the northern hemisphere is tilted away from the sun. So we, in the top where we live, we are experiencing winter. And the southern hemisphere is now experiencing summer, right? Now, up here in the Arctic Circle, they get their first sundown or the first sunset. Now they're going to have 24 hours of darkness, and the Antarctic Circle will have 24 hours of daylight, okay? If you've ever watched that movie, about 30 Days a Night or something. Yeah, so all the vampires go over here because now they can all feast on people for 6 months. No? All right. After winter, we go into our next equinox, which is on or around March 21st. Neither the southern hemisphere nor the northern hemisphere is tilted towards the sun. The sun's rays are directly on the equator. So now we go this way. All right, here's the sun. Northern hemisphere is not tilted towards or away from the sun. You have your equinox. You have spring up here, fall down here. Then it comes over here. Now the northern hemisphere is in summer. Southern hemisphere is in winter, and then it goes around again. Okay, I will have a really awesome Bill Nye video that you guys can watch, and it does help, but you will be able to see how that works. Okay, so that's it for today. I went through it rather quickly, but that I don't want to, I mean, it's actually an hour video, longer than I thought, but hopefully you guys were able to understand. What I do want you to get out of today is your 7 important latitudes, the 5 themes of geography, the spheres of geography, and your Earth-Sun relationship, okay? The march of the seasons. All right, guys, hope you guys are staying safe and being healthy, and just doing your best, because that's all we could do, right, guys? I'll talk to you later. Bye.